Hi everybody, it's Mr. Bennett here again. We're going to today to look at the volume of shapes. So there are pretty well two types of shapes. So they've got those that we call prisms and those that are what we classify as prisms. So the first lot of shapes here, basically it doesn't matter what the bottom is. If you just have that same shape going all the way through, then the volume of that shape is the area of the shaded bit or the end bit times by the length. And if we start looking at the pyramids, they go to a point, so it's simply going to be a third area of the base times by the height. Now the other shape that you will see is going to be a sphere, which is 4/3 pi r cubed. I'll just scroll down a bit further. I've got something I did with my year 10s. So again, the three shapes that you will know: area of triangles, half base times height. We now also could use Heron's formula or half AB sine C to find the area of that triangle. Simply times that by the height to find for a pyramid prism, and for a pyramid it's just simply a third of that area times by the height. For a rectangle or a square, it's just length times width, and again we times it by the height or a third of that for the pyramid. And then we go to look at the area of a circle. It's pi r squared, and the perimeter of that's 2 pi r. And again, same concept is for the prism. We just simply times it by its height, and for the pyramid we go third area of the base times by its height. Now, probably don't know this, but you can certainly put this on your formula sheet. Is the surface area of a sphere is 4/3 pi r squared, and then we go to the volume of a sphere, 4/3 pi r cubed. There's some information about conversion of units for you. Obviously, we have prefixes for how big they are, so kilo being 1,000, milli being 1,000th, and then we're getting on to looking at how you convert from square metres to cubic metres. Alright, so we'll talk about that later. Example out of your textbook is question 8, ice cream cone. So if we're thinking about the ice cream cone there, we need to consider the two shapes that we do have here. So the volume of that shape is going to be simply the hemisphere. Right, so looking at that particular shape there, hemisphere, that's got a radius of 2 centimetres, and then we've got a cone. Now we need to consider the cone has a thickness, and the thickness of the cone is in fact 2 millimetres. So if we know that radius there, then the radius to our particular edge of the thing is going to be 1.8 centimetres because it's got a 2 millimetre thickness. So if we write down our formulas for those, then that's going to be a half of 4/3 pi r cubed, right? And then this one here is going to be simply a third, being a pyramid, of the area of the base, which is pi r squared times by the height. It's probably it is good to actually write down the formulas you're using as a first part of your problem solving. The next thing I could do is I could simplify this a bit here. I could cancel the 2 out there with that and leave that with there. So that will give me 2/3 pi times by the radius cubed. So the radius there is 2 cubed plus a third of the other bit, which is pi, times by the radius. Now the radius of this is 1.8 squared times by the height, which is 6 centimetres. Right, so that's in centimetres. So when we get our answer, the answer will be in centimetres cubed, all right, which is the same as millimetres. So if we go to our calculator and put that into our calculator, so it's going to be 2 divided by 3 times by pi times by our radius, which is going to be then cubed. So we're using that for our cube button, and then we go across and we add 1/3, 1 divided by 3 times by pi times by our radius, which is 1.8. We're going to square that, and then we're going to times that by 6. We go enter, and that will give us an answer of 37.11, and that will be in cubic centimetres. So that will then be 37.11 cubic centimetres, which is in fact equal to 37.11 millilitres. Now what we're assuming here is that the cone is going to be uniform and the fact that the ice cream is going to fill the whole cone. In reality, most times it's just a big sphere that they put in there, so there will be a gap with that. Anyway, thank you for listening. If you have any questions, make sure you catch up with me in class and I will talk to you later. Bye for now.